Hello, everyone. Thank you very much to the organizer team for giving me this opportunity to speak here. I'm very glad to meet you all. It takes 9 hours from Taipei to Sydney. Also, this is the first time for me to Australia and speak outside of Japan and Taiwan. Thank you. My name is Mu Fan, and I have been a Rubyist for 70 years. I started participating in Ruby communities since 2008 and have hosted Ruby community events in Taiwan for more than a decade. You can find me through Twitter and GitHub. My company, 5-Time Ruby, was established a decade ago. We are dedicated to providing professional technical advice and services to business and startups worldwide, utilize Ruby and various technologies. So before starting my presentation, I would like to introduce the main activities of Ruby Taiwan community. RubyCon Taiwan is the conference for the Ruby programming language in Taiwan. It has been held 10 times since 2010, attracting speakers and attendees from all over the world, just like here. It's also one of Matt's most recommended Ruby language conferences outside of Japan. Since 2012, Matt has been invited as a keynote speaker for every edition. Last December, we held the first physical RubyCon Taiwan after the pandemic. We were honored to invite Matt and Tim as keynote speakers. Unfortunately, Matt was injured a week before the conference and could not attend in person. However, it still attracted near 200 attendees and 28 great speakers from over 10 different countries. We hold a monthly sharing and a networking event called Ruby Jam at Peak Lodge office in Taipei. If you happen to be in Taiwan, you are welcome to join. Although RubyCon Taiwan will not be held this year, we will continue the tradition with the community agenda track at Coast Cup. Coast Cup, like FOSDEM in Europe, is an extensive open source conference where over 40 communities gather each time, allowing each one to host its own agenda. This year's event is set for August 3rd and 4th at the National Taiwan University of Science and Technology in Taipei. The call for proposals is currently open, and we would delighted to see you and all your proposal to the Ruby track in August. Firstly, about the agenda, I will briefly introduce how the political party, New Power Party, has been using the internet for its internal political operations since its establishment in 2015. Next, I will discuss the state of the legacy system after 7 years of the development, including the accumulation of tech debt, and the reasons why I choose to redevelop it rather than refactor. Finally, I will discuss the improvements and the challenges in code complexity, security, and agility before and after the renewal. New Power Party, abbreviated as NPP, is a political party established in 2015. In 8 years before the general election in January this year, it has seats in the parliament and was one of the major political parties in Taiwan. Apart from the political spectrum, NPP has been the internet-based political party since its establishment. The NPP website system mainly provides 5 major online functions: membership application, due payment and validity period calculation, a donation, and the most important, internal election, and the CMS. There are party member and non-member accounts in the NPP's website. most party members join the party and pay the membership fee online, in person at any branch office. The party joining requires an identity review by the staffs of the central party headquarters before officially becoming a member. If the review does not pass, the fee will be refunded. Members who pay annual fees, like most online subscription services, need to pay fees once a year. Beware, it's not an auto-renewal one. Annual fee members need to pay membership fee for the year before end of June or December each year, depend on the joining date. If the payment is not made after the deadline, the membership qualification will become expired state and can be recovered within 2 years by payback. Otherwise, it will consider it as leaving the party, and the membership cannot be restored through the payback. The donations, there are 3 kinds of the donation of the MPP site. The one-time donation is the normal one, allows supporters to make a single contribution of any amount. The premium rewards contributors with exclusive party branded items. Lastly, the monthly recurring donation establish a steady flow of support. Technically speaking, one-time and the premium are processed in the same way in terms of payment flow, while recurring donation is another. The unique feature of the MPP, as opposed to other parties in Taiwan, is its implementation of a completely online election system to select its most important decision and legislative entities. The decision-making committee functions similarly to a parliamentary cabinet, with the chairperson elected internally, and the party representative committee is responsible for legislative tasks. Both have a term of 2 years. Let's dive into the internal election process. The official announcement marks the start of the election. And from this point, being a valid party member who has surpassed a certain period of membership becomes a requirement for voting eligibility. Members with expired status, even if they pay the party dues after the election starts, will not be eligible for vote. During candidate registration period, individuals can register as candidates through the system. Once the period ends, the election committee will conduct a qualification review and announce the result. In the question period, members can use election questioning system to conduct public questions to the candidates. 1 day before the voting starts, ballots are sent to the email address of all eligible party members, followed by several days designated as the voting period. After voting concludes, the system calculates the result and publishes them to all party members. The outline the entire election process. The original version was completed by volunteers using Ruby on Rails at the first day of the party's establishment. After that, the party hired an employment with IT background to continue. After generations of party workers, my company took over in 2021. The party suffered from a real absence of software project management, leading to numerous features being developed with little or no subsequent use, or only being utilized once. Certain functionalities were so obscure that even the most senior party staffs were unclear about their original purpose. Some features were over-engineered, incorporating too many unnecessary possibilities, lacking coherent system design. One of the problems with the legacy version is the exceptions caused by data errors happens very often. And due to the lack of error tracking, these exceptions are often only known when users report to party staffs, which also takes me a lot of time to debug. At the same time, the DB migration of this project cannot run normally. So I took over the maintenance of this project in 2021, initially focusing on front-end adjustment and the infrastructure maintenance. However, by the end of this year, 2021, the amendment of the party charter altering the method of calculating overdue membership fees. This leads to numerous issues while aligning with consuming much time in subsequent remediation and data adjustments. Consequently, in third quarter of 2022, the party staff decided to initiate a project rebuild, which formally began in October. The table shows the changes in the main application stack. About the main improvement goals of the new version. First, we aimed to normalize the database schema to ensure data consistency and efficiency. It was crucial to keep only the essential functions. Regarding the election functionality, due to the project's progress, it was necessary to isolate this feature in new system development. This approach allows compatibility between the old and the new versions, while simultaneously enhancing security and reliability. We targeted over 80% unit test coverage, ensuring all significant functionalities are covered by feature testers. This step is vital for maintaining code quality. Our DevOps practice also saw improvement with the implementation of continuous integration and the deployment automation to streamline the development process and enhance productivity. Finally, integrating data from the legacy version into new one was a major goal, allowing us to preserve historical data while moving forward with a more robust and efficient system. About the schema improvement, this is one of the example and the most important one. We separate general user and the party member data, membership, and the membership fee records, which is membership due class, allows member-related functions to be placed only in membership-related models without interfering with non-member users. In the user and membership-related models, I use ASM gem to reduce the code coupling and complexity. In the original user model, most of the state changes related to party members, such as confirming payment, approval, and banning, as well as related operations, were written in the same method called status, and this method was written very confusingly, making it very difficult to maintain. In the new version, I added the ASM state machine with events to handle these state change operations in membership and the membership due class, and use the callback mechanism of ASM to perform corresponding operations around the event occurs. For example, when a membership due is confirmed to be successfully paid, it will change the state from pending to paid through the pay event, which in turn triggers membership pay to extend the validative period of the party member. Looking only at the states of the user-related code, it can be seen that the number of lines has been greatly reduced, and it can pass the ABC size check of Robocop. The biggest problem with legacy version of election functions that there are too many things that need to be done manually by reg tasks, and not all operations can be completed just by reading the documentation. Another problem is that the voting for ballots, there are no need to sign in, and voting can be done just by using a token in the ballot URL, which means that the identity of the voter cannot be actually verified. Finally, the voting data is not encrypted, so when the database is leaked, the voting information is also leaked. The election function was originally part of the website. However, during the development of the new version, internal elections were scheduled to take place. Due to political issues, an early decision was needed for the supplementary election of the decision-making committee. Consequently, the party requested us to expedite the work. We have to develop an independent election website in 1 month, which is compatible with both legacy and new sites sign-in and database synchronization. To be compatible with both versions sign-in, we install and set up the doorkeeper gym on both code base to establish the OAuth authorization server function, so that the users can sign into the election system seamlessly. At the start of the election, a voter roll is generated from the member database to send various notifications and ballots to eligible voters, or all party members. Therefore, it was essential to synchronize the complete member data from the official website. Due to the tight development timeline initially, we used the database synchronization to transfer member data from the legacy system to the voter model on the election system. Later, when we developed the new official site at the launch, we switched to using a RESTful API method instead. Based on the consideration of dispute handling, the election system needs to keep a record of voters' identity. Although the legacy version had a record, it was not encrypted. In the new version system, we use the active record encryption function to encrypt this record to ensure the actual voting data will not be leaked, even the database content is leaked. The process of manually generating the voter list, election announcements, ballot generation, and the email announcements of the election results using reg tasks has been completely changed to use active job. When the election data is created, set wait is used to schedule execution, reducing the chance of errors caused by human operation. Under the tight time pressure, we still successfully completed the development and launched the new election system with a team of 2 people in 1 month, and completed all the result tests and the vast majority of feature tests, resulting in a final test coverage more than 80%. I will talk about the DevOps improvement. Good DevOps design can accelerate the development process of the project. So the goals we want to achieve are to automate all code checks that can be automated as much as possible. Furthermore, we can create an independent sandbox environment for each pull request. When a pull request is merged, it can also be automatically deployed to a production site from the continuous deployment service, reducing possible omissions caused by human operations. The actions need to be achieved goals. We first need to be able to Dockerize the project, writing CI pipelines jobs to automate the workflow, and choose a runtime stack which is suitable for automation. For Dockerizing the Rails project, I have summarized these streams to achieve it. Let me explain one by one. The boxing stream automatically detects the environment of a Rails project to generate a Docker file, and supports using DSL to set additional options. It can also be extended with required options. The OpenBox stream can quickly generate the container entry point for a Rails project. The main benefit is you can run different commands on the same entry point and customize the around tasks like checking database connection or migration. The stream only built in Puma and Sidekick commands. You can extend your own command for other services like Falcon or Good Job easily. The library stream provides a health check reg middleware and is easy to mount in Rails routes. When used together with the boxing stream, it will automatically add Docker health check settings when generating the Docker file. This is a simplified version of my Docker compose file. Since we use GitLab's continuous integration for development, many variables can be applied using the continuous CI integration variable set in the GitLab project or the predefined variables dynamically generated at runtime. Here I need to explain the concept of review apps. If you have used the review apps for your development, please raise up your hand. Oh, wow, so many. The purpose of review app is to create an independent runtime environment for each pull request. This is my GitLab's CI script example. GitLab provides many predefined variables that can correspond to pull requests or Git branches, which in turn allow us to define the variables and the continuous integration environment needed for establishing the review app. In this JavaScript example, there are two predefined variables and can be combined into environment variables or environment name for further deployment. Designing the GitLab CI script is a complex topic, and the time constraints prevent a detailed discussion here. However, I recommend this open source GitLab CI script template. It enables a rapid establishment of a CI workflow, encompassing everything from lint and testing to automatic deployment for typical Rails project. I continually use this in my project as well. This is what it looks like for a pull request in GitLab. We run linters and testers and then build the Docker image. Then we can deploy the review apps by pressing the review deploy job. When a pull request is merged, it will automatically deploy the staging environment and manually for the beta and production ones. Lastly, I want to share my experience of data migration. The migrator tool is crafted for a database to migrating the database data from the legacy schema to the new version schema, related only necessary data. Additionally, it facilitates the transfer of attachment files for the legacy carrier wave to active storage. Given that this tool is intended to one-time use, I created a separate REST engine and hosted it in a distinct repository. It is referenced in the project's gem file and can be removed once after the migration is complete. For the migrator implementation, first define the migration method in the base class. So the subclasses only need to implement the corresponding method to complete the migration. Whether to use validate and callback when saving can also be defined through constant. Defining the scope to export scope can define the scope you want to migrate, or preload the required association to avoid N+1. When migrating the attachments from carrier wave, use the cache_stored file bank method to check if the file exists. Since the project is creating Docker image when built in the CI pipeline when building the Docker image, the REST engine gems needs to be added to the Docker image at this time. And to avoid the security risk of hard coding the Git token in the code, we record the Git token in the GitLab CI variable of the project and pass it to as a Docker build argument during the build process, and set it as an environment variable for the bundler in the Docker file, so that the migrator gem located in a private repository can be installed when building a Docker image. Finally, on the launch day, the migration process took around 30 minutes. We then spend 2 hours on the manual verification to ensure accuracy. Party staffs enter the news and other CMS content following the new format, which took about 2 days. Fortunately, we experienced no data loss or any other accidents, making the process of remarkably smooth. This is my talk. Thank you.